Okay, we learned so many rules for derivatives, and I would like to talk a little bit more about the quotient rule. If you remember, we have this fg, f over g. If you take the derivative of this, the denominator is a g squared, and the numerator will be f prime g minus f g prime, right? That's a quotient rule. And then we use this to derive the, I think last time in my previous video that we did the tangent x derivative, which is, I rewrite that as the sine x over cosine x prime. And then we use the quotient rule. And then at the end, we found, what did you find? Do you remember? It's been a while, huh? That tangent prime is secant square x. Okay, you can use the same idea to get the cotangent. Some book write a cotangent like this, okay, and some book write a cotangent like this. It doesn't matter, it's the same thing. So cotangent, if you take the derivative, it's going to be negative cosecant square x. Okay, so these two, I don't know if you can remember. Actually, I don't really know if you can remember. There are more. Let me write that in a different form. Uh, what about if you take secant x? Secant x. Secant x is 1 over cosine, right? Okay, so you can do either you can do 1 over cosine x derivative, okay, and that will be, so you can take the derivative of cosine as the g, and a 1 is the top f. You can do that, or you can do something that we can use the chain rule later, which is going to be in my next video. So anyway, I can tell you the answer. That should be secant x times tangent x. If you like, you can go ahead and do that. And the other one is the coefficient of cosecant x. That will be negative cosecant x cotangent x. And here it should be multiplication in between. So you can see, I hope you can remember that, but if you don't, you can put them on the cheat sheet. And before that, we also know the sine x prime is cosine x, and cosine x prime, which is a negative sine x. See, we learned the coefficients of, we learned the derivatives of a sine, cosine, tangent, cotangent, secant, and the cosecant so far. For all those 6 trigonometric functions, we learned how to get the derivatives. So this is a very good example. This one and tangent is how do we use this quotient rule. So I'm going to talk a little bit more about we use the quotient rule. Okay, so when you use the quotient rule, you can have like something like an f on top and the g at the bottom, right? And also, I think in last video that I always showed you that sometimes if you can simplify this, you can just simplify this and then take the derivative, or you can just simply use the quotient rule to get the derivative. Now, if you remember that we have the power rule, so if you have x to the nth power, take the derivative, that will be n x to n minus 1 to this power, right? That's what we did. What about if n is a negative number? Let's say n is negative k, and in this case, n is less than 0, and my k is a positive number. So what happens if a is a negative number? So, for example, x to the nth derivative, that's going to be x to negative k derivative, and we can write that as x to the k derivative. And this is a good thing because we have the k as the positive power. And then by the quotient rule, we get the denominator square, so which is xk square. And the numerator prime, 1 prime, 1 take the derivative should be 0. So 1, okay, derivative x to the k minus 1 times x to the k derivative, okay? So this is a 0, 1, because any number constant, you take the derivative, you got 0. So the first part is 0. And then you bring k to top, to front. So it's going to be x and k minus 1. And then this is x to 2k. Okay, right? Then I have a negative k, and let me simplify the power. The power, because we have a x to the k minus 1 and the denominator, these two, they have the same base. Therefore, the power, the new power should be k minus 1 minus 2k, right? The numerator's power minus the denominator's power, and that is minus k minus 1. You agree? Yeah, so it's going to be minus k minus 1. Okay, now can we read it back to n? Because we get a negative k should be n. So here is n x n minus 1. Okay, now you look at this. Look at the beginning and the end. This one to here, you can use the power rule directly. You just bring the n to front, and then you bring the here the power will reduce 1. Okay, no matter whether it's positive or negative, we just use this rule to prove that even we have the n is negative, we still have this. And of course, this power rule applies for not only just the positive power, but also the negative power and also the fraction power. For example, if you have like x to 2/3, like this y, okay, equals to this, then what is the y prime? That will be bring this 2/3 to front, and then here will be 2/3 minus 1. You see that? And then so that will be 2/3 x to negative 1/3. So that is 2/3. And we don't want the denominator. We don't want this negative sign. So here is x to 1/3. Okay. Or this is the cube root. You multiply by x to 2/3. So because you don't want the denominator to have like a fraction power, then you're going to get the denominator is x, so it's a 3x, and the top is 2x to 2/3. So that would be your answer. Okay, so this is one application for the power, use the quotient rule, and then we can figure out, oh, it works for the negative power. Okay, all right, so that is one more thing. Let me try to think about some more example here. This, I give you y equals 5 over 7x squared. If I give you this, there are all different ways to figure this out. You can do this. You can rewrite as 5 over 7x to negative 2. You can do that, right? So y prime will be 5 over 7, that's the coefficient, it stays. And then we bring the negative 2 here, and then we have x to negative 3. Reduce that. So we can have a negative 2 by 5, which is 10 over 7, and then x to the third at the denominator, because it shows positive, negative 3, so we'll bring that down. So you can do that. Or you can use this, you can use the quotient rule. So y prime will be the denominator square, so it's a 7x square and then square. And then the numerator prime, which is 0, times the 7x squared, minus numerator times the denominator prime, which is a 14x. So this is nothing. And then the numerator, I have a negative 70x, and the denominator I have a 49x to the fourth. And then simplify this, numerator, denominator, both divided by 7, so I get a negative 10 over 7, and then the denominator I have x to the third. See, you get the same results. Did you notice that you can use the power rule? You can use the quotient rule. You should get exactly the same answer. It just depends on how you rewrite that. If you like to rewrite that, personally, I would prefer to rewrite something, make it a little easier, because if you want to use the quotient rule, then you have to do like all the steps, and you have to have the denominator and everything. Okay. All right. Now I will give you more examples. So it's going to do like this: y equals. I think we had this. If I remember, I think we had this in last class. Yes, we did. We had this in the last class, right? I give you this y equals 1 minus cosine x over sine x. And then we use the quotient rule, see the denominator square and then the derivative of the numerator times the denominator minus the derivative of the denominator, numerator times the derivative of the denominator, numerator divided by rule. Okay, so anyway, we get the same answer, but I want you to try different ways. So 1 minus cosine x over sine x. So if I rewrite that as 1 over sine x, okay, minus cosine x over sine x, I got cosecant x minus cotangent x, right? And based on what we just talked about, the quotient, just talk about the derivatives of the trigonometric. So y prime trigonometric derivative. So we are going to use a cosecant and a cotangent. Did you see that's cosecant? Here's cotangent. So I get negative cosecant x times the cotangent x, which is the derivative of this. And then I'm going to minus, but the cotangent derivative is a negative cosecant x squared. Okay, and of course you don't want the negative, so I get a negative cosecant x cotangent x plus cosecant x squared. And then what we got earlier is, I guess you probably want to rewrite. Usually people like to use the sine cosine. So that will be, this is 1 over sine, okay, and the cotangent is a cosine x over sine x. Okay. This is a plus and a 1 over sine square x. Then I have sine square x. Okay, so this is 1, this is a minus cosine x. See, we got exactly the same thing as we were using the quotient rule. So quotient rule, or you just simply know the trigonometric functions derivative, you should be able to get exactly the same answer. I think that I want to show you that sometimes you don't really have like just one rule to figure out the question. You can have multiple different ways to do it. Just find out which way works better for you, and then use that as your method. You're going to be okay. All right. Let me see what else I want to talk about. Oh, the higher degree. So if you have, for example, y, which is f of x, okay, and then you can have y prime, which is f prime of x, or you write as dy over dx, or you write a d dx f of x, right? That's all different ways to write it. And then after this guy, this derivative, don't forget, this is also a function of x. Did you see that? See, y is a function of x. When you take the derivative, that derivative is also a function of x. When you draw the graph, this is f of x, right? And then the derivative is the slope of this tangent line at that given x value. So you might want to see the slope goes like from here, it's a pretty big number, and then become, this is 1, right? The slope of 45 degrees 1, and then gets lower and lower, and becomes a little bit of negative, and then positive again. So that's the derivative function. Of course, you're not going to draw it here. This is the f of x, but you can use the little tangent line. You can see what is the derivative. So you can imagine that you're going to use a little thing with the denominator, with the x-axis y. So 1. So whatever, when you have the tangent line look like this, that is your slope. So the value or the measurement of that is the slope, or is the value at that point. That would be the derivative. You plug in x equals to that number, you get a y prime. So that goes back to what we learned earlier, the definition of this derivative. Make sense? So y prime is again a function of x. Then you can take prime to that again, right? Isn't it? It's called the second derivative. So you can write either y double prime or f double prime x, okay, or let me write it, it's going to be d square y over dx square, and here you're going to write f, no, this is okay, or you write a d square dx square f of x. So they're exactly the same expression. That means the second derivative. That means once you have the f of x, you take the first derivative, and then you take the derivative of the first derivative again, so you get the second derivative. So it's very similar if you have like a y to the n derivative. Okay, I because I don't want to write so many primes there, just y to the n. You can write f to the n of x. This is just the expression in our calculus, okay? So it's going to be dny dx to the n. That's just the way to write it, or dn over dxn f of x. So that means the nth derivative. That means you have to take the derivative n times. Okay, so I'm not going into the detail about this because later we're going to learn. And also when you take, I believe that when you take physics, you're going to use this quite a lot, but we don't do that right now. If you want to do that, you can find some question at the back of the book to practice a little bit, but it's really is not that hard. Okay, so that's all. We talk about the more applications of the quotient rule.